Alright, so we were talking about our mean value theorem. Alright, so for our mean value theorem, so hold off on writing on your handout. We're going to write on that in just a second. So this is just, if you want to put it on the back of your handout, you can, or if you just want to put it in your notes. So in general, when we're talking about our mean value theorem, so I'm going to draw a graph. You don't have to write this down. This is just kind of to show you what the idea behind the mean value theorem. So if I have a graph, again, we said that mean means average, okay? So average rate of change is what kind of line? The secant line, yes? So if I have the secant line between any 2 points, pretending that that's a nice pretty straight line, yes? Basically what our mean value theorem tells us is that somewhere along, so let's label this, say, like A and B. Okay, somewhere between A and B, I have to have a tangent line that has the exact same slope as my average rate of change. So I'm just kind of guesstimating here, but it's not too bad. Okay, and that's going to be at some C then. Which makes sense, right? If I have some nice pretty curve, okay, and it's continuous, that my average rate of change is, again, we're using that as an estimate, in this case it's not a very great estimate, of the different tangent line approximations. So if somewhere in between there, that has to be the right estimate somewhere. We don't know where, it's just at some value. What we can use this for is, like, sometimes we can't always find the instantaneous rate of change, but we do have enough information to say, I know that the instantaneous rate of change has to be 2 or whatever, somewhere in between here. Even if I don't know exactly where, I know it has to be that somewhere in between there. Now, we do have a couple of conditions for our mean value theorem. So if f is continuous on, we're going to say, the closed interval, which means I am including our endpoints, and differentiable, what's that mean?
You can take the derivative.
Correct. Now, I don't really care about the endpoints for that, because if it's an endpoint, then I can't really take the derivative or compare the derivative to anything else anyway, because there's not another side. So it only has to be differentiable on the open interval. Then there is a C value such that, so our instantaneous rate of change, or in other words, the derivative at C, equals our average rate of change. So f of b minus f of a divided by b minus a. Okay with that. Now, we have another value theorem. Yes? What was it called?
Intermediate value.
The intermediate value theorem. So we do kind of need to make sure that we know the difference between these. So we are now on your handout. So for IVT, what were our conditions that had to be met for that one?
Has to be continuous.
Yeah, it just basically had to be continuous. Remember, that was even before we learned about derivatives, so we didn't even know what differentiability meant at that point. Now, for our NVT, we do have to still be continuous, but we also now have to be differentiable. Yes, no, maybe. So what we want to look for on your IVT is where the conclusion is a value for the original function. Now, by original function, that doesn't necessarily be f of x, because if my original function was f prime of x, but they're still asking me about f prime of x, then it's still IVT. However, if the conclusion is about a value for f prime of x, or the rate of change, then we're using MVT. Because our IVT just gives us a value, okay? Our MVT gives us a derivative value, or guarantees a derivative value. So we have two different examples here. They're actually the same example with just slightly different wording. So it says a bug is moving along the x-axis. The bug's velocity is differentiable, and selected values are given in the table above. So I'm starting on the left-hand side first. Is there a time c for 0 is less than c is less than 9, such that v of c, which again is your velocity, equals -1? Okay. So our original function, or the function that they give us information about, is what? What's in my table?
Velocity.
Velocity. And they ask us about a what type of value?
Velocity.
Velocity value, yes? So they gave me velocity, they're asking me about velocity, which is why I'm going to use IVT. Are we all with me there? Okay. So, for our work, that's what comes next. What has to be true in order for IVT to work?
Has to be continuous.
Does it tell us that it's continuous?
It says differentiable, so yeah.
Okay, so, but I do need to state that, yes? So, since v of t is differentiable on 0 to 9, is it closed or open? It's open. Okay. It is also continuous on 0 to 9. Yes, no, maybe so. Are we all okay with that? No, we didn't really care about the differentiability for the IVT, but we did care about it because it's what allowed us to say that it was continuous. Now, what was the other thing that we had to guarantee for our IVT to work? Correct. And also, the y value that we want has to be in between two values, yes? So, I'm looking at -1. That's what I want my y value to equal. So, what are two y values on my table that are around that? -4 and
2.
yeah, you could choose any of them. You could choose 0 and 9 if you wanted, right? Because 5 is bigger, -4 is smaller. You also could choose 5 and 9 because 1 is bigger, -4 is smaller. Whatever combination is going to work. Okay? But we do have to say, note, I'm going to go ahead and use 0 and 9 just so that it kind of mirrors what we're going to do with MVT here in just a second. But again, you could have used 1 and 9, 5 and 9. Either of them would have worked. V of, so I'm going to say 0, does not equal V of 9. And -4 is less than -1 is less than 5. So that's my work, okay? Because I'm trying to show why IVT will indeed work. So then our conclusion statement is basically, since we have shown these things, okay, so since V of t is continuous on 0 to 9, the IVT guarantees there is a time C such that V of C equals -1 and 0 is less than C is less than 9. Alright, questions on that? Again, that's just reviewing what our IVT looked like. Now, our NVT is going to be pretty similar. Okay? So let's look over what is different if I'm looking at my word problem on that other side. The setup's the same. Basically, there's only one thing that's different.
Asking for acceleration instead of velocity.
Correct. And acceleration is the derivative of velocity. So it's asking me about the derivative this time instead, which is why I have to use NVT, because that's the only thing that guarantees me something about the derivative. So my work, I'm still going to say V of t is differentiable on 0 to 9 and continuous on 0 to 9. Okay. I don't have any requirements for my y values. However, remember that basically what our NVT conclusion is something about my derivative equaling the average rate of change. Yes? So I kind of need to calculate what the average rate of change is. So I'm going to do that. If they give us 0 to 9 as my interval, that's the interval that I'm finding my average rate of change on. So remember that average rate of change is just V of B minus V of A divided by B minus A. Or F of B minus F of A. In this case, they give us velocity, so I'm using B's. What is V of 9? -4. What is V of 0? 5. What is -4 minus 5? -9 divided by 9 gives us -1. So my average rate of change is -1. And we are continuous and differentiable. So basically what we can say then is since V of t is differentiable on open interval 0 to 9 and continuous on closed interval 0 to 9, there must be a C such that A of C equals -1 and 0 is less than C is less than 9. There we go. So So this is both of these are pretty common types of free response questions on the AP test. Now this would only be like part A or part B, right? But there'd be other stuff to do with the table, okay? But those are pretty common ways for them to ask it. So what questions do we have about IVT versus MVT?
So when you're doing MVT, you always have to use the start and end point.
Not necessarily. Like you have to use a starting and ending point. Basically, I want to pick 2 points such that my average rate of change is going to equal whatever they're wanting me to prove that the derivative equals, right? Which in this case was like -1. So usually I'm starting with whatever interval that they give me. That's usually going to be where it's over. It doesn't like. I'm not going to say it's never not there, but it doesn't necessarily have to be there. But like most of the time, yes, it's going to be. If I do the average rate of change between the starting and ending value, it should equal whatever it is you're trying to prove. Other question? Alright, so let's do some more MVT problems. So you can either do these on the back or in your notes, whichever one. So this type of problem is a very common like multiple choice question. Okay, the ones that have like an actual f of x. Okay, and we're just gonna solve for c. So it says determine if the mean value theorem applies. If it does, find all values of c on the interval that satisfy MVT. So what were the 2 things that we said have to be true in order for MVT to apply?
It has to be
F of x is
continuous,
and
differentiable.
is f of x going to be both of those things?
Yeah,
Because
it's a polynomial.
yes, I don't have to do a lot of proving because I know that it is that. Okay. Now, if it was like a trig function like tangent or a rational function or like a logarithmic function, something like that, we would need to make sure that it is going to be continuous over the interval that we're wanting to do. Otherwise, the answer would be no, MVT does not apply if it is either not continuous or not differentiable. So then, like I said, the 2 things that we're going to need are our average rate of change and the derivative. So here we want our average rate of change between 0 and 2. So I'm looking at f of 2 minus f of 0 divided by 2 minus 0. What is f of 2?
-8. Oh, 0.
There you go. So 2 to the 4th is
16.
16. Minus 8 times 2 is also 16. So we do get 0. What is f of 0?
0.
Also 0. And then our 2 minus 0 gives us 2. So what do we get?
0.
0. Right? 0 divided by 2 is going to give us 0, which is fine. Our average rate of change can most definitely be 0. And so now what we're wanting to say is because my MVT most definitely applied because it's continuous and differentiable, okay? I know that there must be somewhere that my derivative equals the average rate of change. So now I'm trying to find, because it wants us to know the actual value of c. So we have to find that spot where that doesn't fit. So now I need my derivative. So what is our derivative?
4x cubed minus 8.
Cool. And we want to know what value is going to make that 0. So how would we solve? And? So we get,
8 over 4.
which is also
2.
2. Yeah. And then how do I get rid of it? Cubed. Cubed root it. So I get the cube root of 2. Is that going to be a nice pretty answer? No, so I'm leaving my answer like that. Because this could most definitely be a non-calculator active, and you would just see that as one of the answers if it was multiple choice. The only thing we do have to consider, though, okay, is that we do have to make sure that this c value is on my interval. Is cubed root of 2 in between 0 and 2. Yeah, it has to be positive, so it's going to have to be bigger than 0. And if I'm taking the cubed root of 2, that means it's going to have to be smaller than 2. Yes? So it's going to have to be on that interval. So then my c value, this is my c value, that makes that true. Now, common thing that might happen, like if this had been a square, right? What do we have to add when we take the square root? Plus or minus. Would my minus have been in the right interval? No. So then you would want to only choose the positive one. Because especially like on a multiple choice question, like it would probably say positive 2, negative 2, and then plus or minus 2. And so some people would choose the plus or minus 2 because that's technically what you get, but the positive square root of 2 would be the only one that's in my interval. Does that make sense? So we always have to go back to that. Alright, what questions do we have there? Yes, no, maybe so. You ready for the fun problems? I think they're fun. Alright. It's just a lot of words. None of them are very big. We can all read them. So, Mrs. Bennett is late for school because the Starbucks line is backed up. The speed limit is 60 miles per hour. Assuming that she is going a continuous acceleration, she was going 55 miles per hour as she passed a cop, and after 30 minutes was going 57 miles per hour as she passed another cop 35 miles away. Would she be telling the truth if she told her students that she did not speed to get to work that day?
How far away do you live?
I don't live that far anymore. I used to live that far away, but I don't anymore. Because I just take the turnpike to get to school. Alright, so what do we know?
That you're going 60 miles an hour.
Well, I
That you
was
were-
not.
No, that you were not going 60 miles an hour.
I was not going 60 miles per hour at the 2 spots that I was clocked, yeah? Okay, but our question is there some time in between, yes? Where we would have had to go that? Yes, no, maybe so. Okay. Okay. So when we're talking about like average speed, yeah? So just like speed of 2 things. What does speed equal?
Distance and time.
Okay. Do we have a distance? So this is my average.
35 miles.
What?
35 miles.
Oh, okay. So this can also be labeled as our average rate of change. Okay. 35. Alright. What was our time?
30
Hmm?
30 minutes.
Okay, what's another that we could write that? To make it nicer. For what we're talking about.
Half an hour.
Yeah, it's half an hour, right? Because we're talking about miles per hour, so it makes more sense for us to put this in terms of this was miles, for this to be in terms of hours. Yes? So again, this is just average speed, okay? We all with me there? So, what is 35 divided by 0.5? 70 miles per hour. And that's our average speed, or our average rate of change, yeah? So what do we know then? If we had a continuous acceleration, okay, right? If I go backwards to get from acceleration to velocity, if my acceleration was continuous and differentiable, then so would my velocity, okay? So we can say v of t is continuous and differentiable. Yes? So therefore, by mvt, yeah, there had to be some v of c that equals what?
70.
70, right? Because that was our average rate of change that we found. Now, we found it a little bit different than our f of b minus f of a, right? But it's still my average rate of change. And that's what the f of b minus f of a stuff represents. So we still know that this had to be 70 somewhere. We don't know where, but it had to be 70 somewhere in between there. Yes, no, maybe. So did I speed?
You lied.
So no, I didn't tell the truth. Which is also, this type of question is kind of interesting because in some states they actually use this type of technology to write people tickets. Because it's like if you're on the turnpike and they clock you going a certain speed at like your first checkpoint, right? Like where they scan your like little toll tag thing. They can take your speed and time and the distance between those two things at your next checkpoint to figure out if you had to speed somewhere in between there. And then they will write you a ticket and send it to you in the mail.
Which states?
I'm pretty sure California is one of them.
Okay, so not going
Yeah, at least don't speed in California, I guess. Alright, what questions do we have on this one? Yes, no, maybe so. So, let's see. What's our next one? Okay. This is another table problem. It's just slightly different than the one that we saw on our so it says the function g is differentiable for all values of x. Selected values of g are given in the table above. Is there a c on the interval 0 to 6 such that g prime of c equals 2? Give a reason for your answer. So what's my original function that they give me stuff for? What's on my table?
G of X.
G of x. Okay? And what are they asking me information about? G prime of x, right? Because I don't want to say, oh, a derivative, it's automatically in dt, because if my table gave me prime values, right, I would still be using IDT. But my original function is g. They're asking me about g prime. So I am wanting to use NBT. So what are the two things that we have to say?
Continuous.
Yep. Is it? Do I know that?
Yeah.
How do I know that?
So it's differential.
So g is differentiable for all x. So g is also continuous for all x. Alright, so that is my condition. I have to meet my condition. Yes, no, maybe? Then what is it asking us about? Like, what is it wanting us to actually prove?
The derivative is 2.
Okay. Now, our MBT says that my instantaneous velocity or my instantaneous rate of change has to equal my average rate of change. So we said the two things we need are the derivative and the average rate of change. Well, they give us the derivative on this one, so what do we still need to find them? Average rate of change. Okay. Again, I'm usually going to start with my endpoint, hoping that that gives me the right spot. What is g of 6? 10. What is g of 0? -2. So we get what?
2.
Right, we get a 12 on top divided by 6. So we do indeed get 2. Yes, no, maybe? So what can our conclusion now be? Therefore, basically we're just restating this, right? There is AC between 0 and 6 such that g prime of equals 2 by what? MBT. Did I do a whole lot of math there? Not really, right? I subtracted some things and did some division. But remember, you do have to write in complete sentences here, and you do have to write out your conditions. So we cannot just assume that the reader knows that you know that the conditions have been met. You have to state that those conditions have been met. What questions do we have there? We will stop there for today.